we've got two logs on that left side. So it's kind of like when you have x squared and x. You cannot isolate the x because you have x squared and you have x. Which one do you isolate? You got two versions of it. Kind of the same thing here. We have two logs, so which one do we isolate if we're looking at it from the perspective of what we know to do so far? You can't make that choice. You have to use the properties of logs to put these together. So we are adding the two logs, so that becomes a single logarithm, and it is the product. Now, since the 9 right here is just a constant, even though it comes second, I'm going to put that in front when it comes to the multiplication because it's a constant multiple. Order of multiplication doesn't matter. Now, if it's a subtraction problem, that order does matter. Okay, when you divide, it does matter which one goes on top, which one goes on the bottom. But when you're multiplying, 9 times 2x plus 9 is the same as 2x plus 9 times 9. Okay? So we condense that to a single log. Now we're back in the case that we looked at the other day, case 2, where we get the log by itself, the variable's inside the logarithm. The only way to get it out of the logarithm is to put it in exponential form. So that's 6 to the first is equal to 9 times 2x plus 9. Now we just have a linear equation. We've got 6 is equal to, distribute that 9, 18x plus 81. Subtract the 81 from both sides. I am not in the mood to mess up basic arithmetic this morning, so I am going to use my calculator. Negative 75. And then divide that by 18. I know they at least reduce by 3. X is equal to negative 25 over 6. Now, especially since we're dealing with logs, you definitely want to check your answer, particularly if it's a negative, because remember, you are not allowed to take the log of a negative number. So if we plug that negative 25 over 6 into this log over here, and we get a negative inside the log, then that's not actually a solution. It's an extraneous solution. So always check your answers, particularly if they are negative. Remember, you have to use change of base to put that in. And that did give me 1, so we're good. Negative 25 over 6 is the solution. All right. Look at a subtraction example. Log base 9 of x minus log base 9 of x plus 1 is equal to 1. Now, I don't know that you will honestly ever run into this situation, but you should always make sure that your logs have the same base. You can't put them together if they don't have the same base. So just be aware of that. So since this one is subtraction, that is our quotient property. So whatever comes first goes in the numerator, whatever comes second goes in the denominator. So we've got log base 9 of x over x plus 1 is equal to 1. Now we're right back at case 2. Logs by itself, variables inside the log. Only way to get it out is to change forms. Put it in exponential form. 9 to the first is equal to x over x plus 1. Now, this is kind of like a rational equation, but they're always going to be simple rational equations. We don't really have to go through all the process that we went through in the warm-up. Really, all we need to do is multiply by the denominator, like we're moving it to the other side. Really, just like if we were dividing by 3 or something, we would multiply both sides by 3. We're just multiplying both sides by the denominator to move it to the other side. So we have 9x plus 9 is equal to x. Now, normally I don't move the bigger variable, but since that x is already by itself on the right side, I am going to subtract the 9x from both sides and then divide both sides by negative 8. And negative 9 over 8 does not reduce. And I've got another negative solution, so I'm definitely going to make sure that I check that. Negative 9 over 8 stored as x. Log of x. Oh, wait. I really don't have to check it. When I start to plug it in right here, I've got the log of x. X was negative 9 over 8. I cannot take the log of a negative number, so that gets thrown out. That is no solution right there. Now, no solution does happen, okay? It does come up. It is a possibility, but I would just be a little wary of marking it out just in case something went wrong. So let me just remind you that graphing is always an option to check. And the great thing, let me show you how I'm actually typing this in, okay? I'm just going to type the equation into Desmos here. Log, you do shift and the dash button, and that will bring up your subscript, or you can go down here. I think you can go down here. Where'd it go? Nope, maybe not. You have to do the shift and the dash. That'll get you your subscript. So what was it? Log base 9 of x minus log base 9 of x plus 1. Okay, of x minus log base 9. You do need parentheses around that x plus 1. Okay, now you don't type in the entire equation. You got to plug in the left side. You got to plug in the right side. And because the right side's a constant, you have to put y equals. Okay, because the right side's a constant, you have to put in y equals. So when we look at the graph, if we solve by graphing, what are we looking for? Where they intersect. So I'm looking over here, and it's not looking like they're getting any closer. Okay, I keep scrolling over here, and they're just hanging out steady right here. I mean, the 1 is always going to be there at 1, but the log is hanging out right there at the x-axis. It's not really moving. Look at that y value. It's hanging out at negative 0.007. Now, it is technically changing. It is getting smaller, but it's rounding here. Okay, so those are never going to intersect. If they never intersect, there's no solution. So before you write that down, before you totally throw out your solution, I would suggest graphing it to confirm that. And obviously Desmos makes it a lot easier to graph than trying to graph it on your graphing calculator. Now it is possible to graph it in your graphing calculator. You just have to use change of base. You'd have to do log of x divided by the log of 9, etc. to be able to put that in. And then obviously zooming and moving around is not as convenient, but you can do it with that calculator as well. Okay, couple more here. Let's look at this scenario. Another addition problem, but this time we have logs on both sides. So log base 8 of 4 plus log base 8 of x squared minus 1 is equal to log base 8 of 50. So we are adding these two logs. So that is our product rule. We multiply what's inside those logs. And on the right side, we just have that log base 8 of 50. There's nothing to do with it. You just leave it. And I don't know why all of a sudden my log base 8 turned into log base 4. It's still log base 8. I guess I was thinking about the 4 that I was getting ready right there. Okay, so we have the same log on both sides. This was the very first scenario we looked at. You just take what's inside those logs and set them equal. This one is a quadratic. So normally I would want everything on one side. I'd want it equal to 0. But this is, I only have the x squared term. So really factoring is not required here. I can just isolate the x squared.